Once you take the proton off and you look at that structure, what's going to make something more acidic?
Resonance.
Resonance, right? So in this case, if I take a proton from here or here, which one is going to give me more resonance? The left one or the right one?
The left one?
Yes, because I can put resonance into this ring or I can put it to here. If I take it from here, I can only go to there. I can't take it. Does that make sense?
Yeah.
Okay. For my next one, which proton is going to be the most acidic?
When I did it, I put the H that's attached to the triple bond just because that's on the pKa chart we have.
Yep. So this is a good way to remember it. SP is more acidic than SP2 is more acidic than SP3. An alkyne proton is 25. An alkene proton is 44. An alkane proton is 50. Does that make sense for hybridization? So when you go through and look at strengths of acids, hybridization is an important thing. Would you guys like me to make you a video on acid-base chemistry? Okay, I will make you a video on acid-base chemistry for all the rules. So you guys have it, so you're better at it. Okay, looking at this one here, which one's our most acidic proton?
Is it the H2N?
Nope.
Is it the H on the bottom right?
Yep, because what is this functional group called? This is an alcohol. This is an amine. This is a carboxylic.
Don't say it. Don't.
Acid.
Carboxylic acid. Yeah, it's in the name. Your carboxylic acid's pKa is about 5. Alcohol is about 16. Amines about 38. So that carboxylic acid is going to come flying off if you look at it incorrectly.
Okay.
Make sense?
Alcohol is 16.
About, yeah.
Okay.
It's about the same as water. Technically, the pKa of water is 15.7, but I don't think you need to be that specific. So my best friends live across the street. That's one of the reasons I moved to Virginia. And I got their dog a steak because she helped me get a date as a thank you to the dog. Maggie's my best friend. And so I bought her a sirloin steak that I cooked up, and she's just like passed out, just like she's got steak coma. So I will upload a photo later. I'll send a photo to this later. So I'll send it to you guys. Yeah, so I took a photo of me and the dog, and someone was like, "Oh my God, that dog's so cute." And she's like, "She looks really adorable. What's her name?" I'm like, "Oh, this is Maggie. She has a good home, but I don't have one." And she laughed, and it worked. So I was like, "Thank you, Maggie. I owe you a steak." So our last one. Where is our most acidic proton?
It's the H on the bottom right. That's one of the groups, is like -9.
This one here? Yep, that's going to be our most acidic one. Again, what's the key indicator? Once I remove it, what am I going to have more there? Resonance. Because I can move my charge up to here, I can move it to here. All right, so we're going to take a quick interlude into acid base because this is something I realize you guys don't know. So when we think about strengths of acid, what is the most important thing first? What is the first thing you should think about when you're thinking about strengths of acid? What atom it's attached to? What atom what atom the proton is attached to? This is your most important thing. All right. So if I think about CH, NH, OH, or FH, which one is the most acidic one? I arranged them in the
FH.
period. I arranged them in a periodic table, and you just said Cole FH.
Yeah.
If I'm comparing atoms in the same period, left to right, the atom that's furthest to the right, that's going to be my most acidic one. Okay.
This is Oreo, right?
Mm-hmm.
Okay.
And then if I compare atoms in the same column, which one of these is my most acidic one now? At the top or at the bottom?
Bottom.
Yep, if I'm comparing atoms in the same column, right, the same group, the further down it is, the more acidic it is. Okay, so just to give you pKa values, I'll write pKa values here. I think that might be 1. I forget what HF is off the top of my head, but those are your pKa values, give or take. Does that make sense for this? This is the most important thing that you look at. All right, the next thing is resonance. So which one of these is more acidic? They're both attached to an oxygen, so that doesn't help me. But if I remove the proton, right, what does the one on the left have that what does the one on the right have that the one on the left does not have?
Resonance.
Resonance. Resonance is your next most important thing. When I remove the proton, I can move this here like this, right? I have resonance. There's no resonance on that one on the left. Does that make sense? So now when I'm comparing the same type of atom that my hydrogen's attached to, I look at resonance. Resonance is my next thing, okay? Next up, inductive effect. So we have acetic acid and trifluoroacetic acid. Which one of these is more acidic? Well, they both are attached to the same type of atom. They both have the same resonance. What's the only difference now between these two?
The one on the right has an electronegative atom.
So something is more acidic, the more electron density we pull away from it. So the more electronegative atoms you have near it, the stronger the acid it is. I'm pulling away electron density from that. So the pKa of this carboxylic acid is 5. TFA, I think, is -5. No, it might be 0 or 1. I forget. We'll say 1. But does that make sense now for this is called the inductive effect. The more electronegative atoms I put near it. Are you guys okay with this, Melissa? Oh, go ahead.
I've got a question on the last one.
Mm-hmm.
Did you say that the more resonance it has, the more acidic or less acidic?
More. Once you take the proton off, the more resonance you have, the more acidic.
Okay, thank you.
Okay, so are you guys okay with that? And then finally, the last thing we worry about is our hybridization. So if I have a sp3 versus an sp2 versus an sp, the more S character we have, the more acidic it is. pKa 50, pKa 44, pKa 25. So this one is 25% S. This one's 33% S. This one is 50% S. Makes sense? So the more S character we have, the more acidic we have. These are the 4 rules that you should remember, and I went in order. What it's attached to, A, attach, R, resonance, I, inductive effect, and then this would be hybridization. Does that make sense for our rules for this? Do you guys feel better now about choosing your acids?
Can you explain this one more time?
The more S character you have in your hybridization, so this is 50% S, 50% P, the more S character you have, the more acidic it is. Here, this one is 33% S, 66% P. And here, this is 25% S, 75% P. So this just has to do with the how easy of an explanation would you guys like for this? The atomic orbitals are just aligned up to make removing this proton easier. So sp has a better alignment to remove the proton than sp2 than sp3. How are you doing with that, Melissa? Good? Kind of okay? So remember, just go by what it's attached to, then resonance, then inductive effect, then hybridization. Go in that order. How are you guys doing with that? Any questions?
Yeah, I have a question.
Mhm.
Where did you get 50 and like 44 and 25 from?
Those are the pKa's, and that's your pKa table.
Oh, okay.
Like
So
I
those
said,
are the keys.
yep, you can just memorize the table if you want. That's what I did.
Okay,
I was
thank you.
nervous when I took organic, so I read the textbook before the summer I took it and did all the problems in the textbook. I heard it was a tough class, so I wanted to be prepared.
That's one way to do that.
I'm also weird. You guys know that, so look at me now. I think I told you guys the story about the kid that I went to college with, that he's an NFL player now worth millions, and here I am teaching chemistry. So make the most of your college experience, I suppose. Okay, IUPAC names. What is the first thing we do when we do IUPAC names?
Find the longest parent chain.
Mm-hmm. Which one do you guys want to do first? Or do you just want to go in order? Let's go in order. So I'll do one. I'll let you guys come up with 1, 2, and 3, then we'll go through it. So take your time. I'm gonna look at my phone. I'm gonna go to Reddit while you guys are doing this. If you guys look, there's Maggie. See, she's still passed out from the steak.
Wait, I think you had pictures of these dogs in your slideshow, like when you introduced yourself.
Oh, those are those two were my dogs. They're still doing fine. They're down in Phoenix.
Okay.
They're keeping my mom company because she's quarantined. How's it going? Okay, what'd you guys get for the first one? Are you still working on it?
I don't know if this is right, but I got 5-ethyl 3-isopropyl heptane.
What is incorrect with that right off the bat? Not to break you or anything,
No,
just
no, it's fine.
what's the one thing that you cannot have in an IUPAC name?
I don't know actually.
ISO and TERT are not IUPAC names. So isopropyl, isobutyl, tertbutyl, those are not IUPAC names. Those are common names. So that's one thing to watch out for.
Okay.
That's a common mistake that I think just about almost everyone makes. So what's our longest chain though? What'd you say it was?
I got heptane, so just like the
Yeah.
longest one at the top.
Heptane is going to be our longest chain here, right? So if I go from right to left, just counting, it doesn't matter if I start here or here because that's going to give me the same. Oh, that's going to give me the same things, right? So do I end? Which carbon should I go to? Should I count from the black to the blue here? The black to the green? Which one should I go to?
When I did it, I did green to red.
Okay, well, green or black and red are interchangeable, right? So that would be correct. So we should have 2-methyl, right? And I'm just writing this down. 1, 2, 3. 3-ethyl. And again, I'm just writing this down. And then 4, 5, 5-ethyl, right? Those are our 3 groups that we need to put. What was the one piece of advice I gave you guys yesterday to help you out when you are doing your numbering and you're doing your naming and stuff like that?
Be consistent.
Be consistent with how you're doing it. Also, number your drawing. 1, 2, 3, 4, 5, 6, 7. That way, whatever TA is grading your tests will see what you're thinking. And they can say, oh, this was the long chain that they did. Then they'll be able to say, I know exactly what such and such was thinking, right? So now, what's the rule we say for when we put our functional groups? How do we arrange them? By numbers or another way?
Alphabetical.
Alphabetical. So it should be 3, 5 diethyl, because we have 2 ethyl groups, 2 methyl heptane. Does that make sense?
Is there a dash in between the 5 and the diethyl?
Oh, yeah, sorry.
Okay, just wanted to make sure.
Yep, it's not the biggest sin to make, but yeah. If you're doing this on like Springer or Spring Hill or whatever, you'd probably need it if you guys do the online assignments. But I'm really sad because I was going to teach organic this year. You guys would have had me.
That would have actually been so fun.
Rip.
I would have made sure that like my whole schedule just fit like your schedule.
Yeah, I would have been so happy.
Same.
That's okay. You have me over this online thing, so make the most of it. Okay, let's try 2. So when we have ring and a chain, which one takes priority?
Ring.
The ring.
The longest one. So do I have more carbons in a chain or more carbons in the ring?
The ring.
In the chain.
In the ring.
Oh.
Because I have 2, 1, and 1, right, in the chain, and then the ring there's 5. So what should I call what's the base name for this?
Cyclopentane.
Cyclo, because it's a ring, and there's 5 carbons, pentane.
So your chain can't go through a
No.
ring if it's the longest. Okay, I was super confused when I first saw this. What if there was a gap in the pentane? You could do that? Oh yeah, that's just like the other one. Never mind, that was stupid.
You just count if you had a chain that had more carbons, then that chain would be it. So like if imagine you had this like this, so 6 like that, then that ring would be the attachment. Okay, so now which carbon is my number 1? Does it matter?
Yeah.
Is it the first, like the little peak? Like,
I would make this one my
Oh.
number 1.
okay.
So I
Really?
would say 1 ethyl,
Oh.
1, 2, 3, 2, 3 dimethyl. Like that.
I always forget you can number either way.
Because what did I don't remember who that was. Is that Mag or Morgan? I don't know who said it. What was what I say about numbering? You always want to be what?
Consistent.
Consistent. As long as you're consistent with your numbering, and this is why you number yourself. That way whoever's grading can say, I know what Bella's thinking. I know what Melissa was attempting, right? Who knows what Morgan was doing, what evil is in her heart. JK. She's not that evil. Maybe she is. I don't know. But this is just the idea, right? Is that you just number and just be consistent, okay? When you learn more functional groups, you're going to have priorities of functional groups. You'll learn that a little bit later, but for now, this is not a big deal.
I have
Okay,
a question.
go ahead.
Did you start your 1 right there just because there's like an ethyl group there?
Mm-hmm.
And instead of just like being 1, so it was, instead of just being a methyl?
Yep,
Okay, thank you.
you're welcome. Okay, and again, finally, let's do our last one. What's our longest chain?
Is it the top left end to the top right end?
No, that's a good question. Let me take a look. So from here to here. That's my longest chain. If you're ever unsure and you have time in an exam, remember, make the most of your time. If you're ever unsure, this is why I also recommend that people use colored pencils. It's one of my recommendations. Green to blue is 3. Green to that red is 1, 2, 3, 4, 5, 6. Green to orange is 1, 2, 3, 4, 5, 6, 7, 8. Green to pink is 1, 2, 3, 4, 5, 6, 7. And green to green is 9. That's my longest chain. So this is going to be my longest chain. Are you guys see that? Yep. So then what's 9?
Nonane.
Nonane. What's 30?
Trenta.
Very good.
Wait, was that right?
It's close. Yeah, it's like if you know Spanish, we use
That
Latin.
sounded like 30 in Spanish.
Yep, Latin is very close to
Yeah.
Spanish, right?
I was like,
So which one are we going to make number 1? Are we going to make this number 1, or are we going to make this number 1? The left one or the right one?
Left.
Left, because that'll give us lower numbers. So we have 2, 3, we have a methyl, so 3 methyl. 4, we have an ethyl, and I'm just writing them out, and I'll rearrange them once they're drawn. Now, how do I draw at 5? We have something. How do we draw 5?
Parentheses.
The non-IUPAC name would be isobutyl, but that is incorrect, right? So we would say 5 dash parenthesis Now we draw our longest chain here, 1, 2, 3. So the back end of this is going to be propyl. And then we have a methyl, 1 methyl propyl. So it should go 4 ethyl, 3 methyl, 5 1 methyl propyl. And that's how we name molecules. How are you guys doing with nomenclature?
Can you explain why you put propyl?
Because when we name, and I'm going to erase this bunch of this stuff here. When we go here, right, this is our main chain, like this part right here.
Mhm.
Do I have on my side chain, do I have branching?
Yes.
When you have branching on a side chain, you find the biggest chain. In this case, it's, hold on. In this case, it is, as my dealie goes weird, right? In this case, my biggest chain is going to be 1, 2, 3. So that's where the propyl comes from. Does that make sense?
Okay. And then you just put 1 methyl
1,
because it's
2, 3. Yep, I start numbering away from the chain. So that's why that's 1 methyl propyl. Are you guys good with that?
Yes.
Wait, what did you say? I mean, what was the order of the names again?
4 ethyl goes first,
Mm-hmm.
then 3 methyl,
Okay.
and then 5 1 methyl propyl.
So when so like for 5 and 3, because they're both methyl, would you put it in like
You go by the base propyl.
Oh. Oh, okay.
That's the only reason that goes first.
Okay. Thank you.
You're welcome. You guys are doing fine, so don't panic. Draw the structures for the following. So I'm going to walk you through how you should do this to make your life easier. As we talked about, always start with the base. Cyclopentane, 1. Okay, when I draw numbers, all I have to be is consistent, right? I could call this carbon 1. I could call this carbon 1. It doesn't matter, just as long as I'm consistent. So just because to me it makes sense to make 1 at the top, I'm going to say 1, 2, 3, 4, 5. At 1 and 1, I have 2 methyls. And at 3, I have a methyl. Does that make sense? I could have very easily have drawn this here and said, this is carbon 1, this is 2, this is 3. And again, I would still just have methyl, methyl, methyl. And the only rule is that I'm being consistent, right? This is why I recommend you number your carbons when you do nomenclature so your TAs can see what it is you're doing, right? And they can say, okay, they understand the numbering. So this would be 4 and this would be 5. Numbering your carbons is always something you can do. Okay, next one. 4 ethyl 3,6 dimethyl octane. Again, start with your base. 1, 2, 3, 4, 5, 6, 7, 8. At 4, so I could count this way, right? I can go 1, 2, 3, 4, 5, 6, 7, 8. I easily could have counted left to right, but I'm doing right to left because it doesn't matter. At 4, I have an ethyl. 1, 2, 3, 4. At 3, I have a methyl. And at 6, I have a methyl. Do you guys see that? Does that make sense to you on how you should draw stuff? Draw the chain, your base chain, whether it's a ring or a chain or whatever. Number the carbons in a way that makes sense to you, and then just add the stuff based on your numbering. Okay? Circle the best answer for these 5 multiple choice questions. What are the formal charges on the indicated carbon, oxygen, and nitrogen atom? All right. This carbon, is that going to be a neutral charge, or will it be neutral, or will it have a charge?
It would have a charge.
Wouldn't it have a positive charge?
It's going to have a charge because it doesn't have 4 bonds, right? Carbon with 3 bonds and a lone pair is negative. Carbon with 3 bonds and no lone pair is positive. So I can immediately say, and this is what you should do for the multiple choice, that immediately eliminates 3, 4, 5, and 6. Okay. Oxygen with 2 bonds and 2 lone pairs. What's the charge of that? if oxygen has 2 bonds and 2 lone pairs?
0.
It's going to be
Zero.
0. Oxygen wants to have that. So that eliminates this one. And so just to double check, nitrogen with 4 bonds and no lone pairs is in fact positive. So 2 is my answer. Does that make sense? If you know what the correct number of bonds is and the correct number of lone pairs that atoms want to have, you can easily go through that. Or you can just do the formal charge calculation. If you don't remember, formal charge on an atom equals number of valence electrons minus number of bonds minus number of lone pair electrons, right? And if you do that calculation for any atom, it'll tell you what that charge is, okay? What is the hybridization of carbons A, B, and C? What is my hybridization of B? Does it have any double bonds? Or what's the hybridization of A?
Isn't that
How many pi bonds?
sp3?
How many pi bonds does A have? Sorry,
One.
A. Nope,
1?
it has 2 pi bonds.
Oh.
Because you have the double and then the triple, right? So if I have 2 pi bonds, what's my hybridization?
SP.
SP, right? So that's going to eliminate 5 and 3, all right? So B, does that have any pi bonds attached to it? So what is the hybridization if you have no pi bonds?
SP3.
That is correct. So that eliminates 1. And C, how many pi bonds are there attached to it?
1.
So then that makes it sp2. So 4 should be my correct answer. Good on that one?
I've got a question.
Mhm.
So this is probably like my worst part of this whole test, like the hybridization and stuff. Is it based off of the number of bonds, the sigma and pi bonds, or if it has a double or triple or single bond, or the atomic orbital?
How many things is that carbon attached to in that alkyne? This is A. How many things is it attached to?
2.
So I need an S and a P orbital. That's why the hybridization is sp. Here, it's a carbon double bonded to oxygen, to a carbon, to a carbon. How many things is this carbon attached to?
3.
So I need an S, a P, and a P. That's why this is sp2. B is attached to 3 hydrogens, and this carbon is attached to 4 things, right? So then it's going to be an S, a P, and a P, sp3. Does that make more sense?
Do the S and P's correlate to specific kinds of bonds?
So sp is alkyne triple bond. sp2 is a double bond. sp is single bonds. sp3 is single bonds.
I have a question.
Mhm.
So I thought that when you have 4 bonds,
Mhm.
that it would be sp3 for some reason. Like if you had like
So
methane,
here at A or B or C, which one are you talking about?
like methane, like
Mhm.
C and then the 4 hydrogens,
Mhm.
I thought that would be like sp3.
That is sp3.
Because
Okay.
there's 4 like electron groups.
It has 4
Attached to it?
electron groups, right? It's attached to 4 different things, right?
Yeah.
So I need an S, a P, and a P, right? I need one of those orbitals for each thing. So this is sp3. If I had a carbon here like this, how many things is this carbon attached to? How many unique things is that carbon attached to?
3.
So I need an S, a P, and a P. It's attached to 3 things. This will be sp2. Does that make sense? Are you
I've unlocked
feeling?
the key. I finally understand.
I taught you this last year, man.
I didn't think I'd need it.
That's fair.
Also,
So
I hate it.
That's also fair.
Sorry.
It's all right.
So if I had like a carbon and then a triple bond next to it and then a single bond to the other side, would that be sp?
So like this, I'm going to draw here on the board for you. like this right here,
Yes.
how many unique things is that attached to?
2.
2, so an S and a P.
Okay.
SP.
that
Make sense?
Yeah, thank you.
You're welcome. Okay, guys, it's that time again. I'm gonna pop out and pop right back in because we're just about done. I'll be right back. Sorry. Next time we'll do this, we'll use someone else's so that they have a license. Be right back.